Okay, good morning, grade 3. It's teacher Ellie here. So, unfortunately, I am facilitating K2's assessment or evaluation. That's why I cannot do a Google Meet class today, but we will still continue with our lesson. And last meeting, we started from when we started in the middle of chapter 4, which was in page 51. And we actually finished it till the last page of chapter 4. What's our chapter 4? Forces and magnets. So last meeting, I promised you that I'm gonna be showing you videos about those experiments that we cannot do in school. So let's begin. So I'm sharing my screen now. Okay, that is me. Okay, I'd like to please turn your books on page 51. There is this experiment about two bar magnets that we had that we were supposed to do in the classroom, but we can't be able to. So I'm going to be showing you a video about that, how two bar magnets repel or attract each other. Okay, ready? And one more thing, I know that you will not be able to hear the audio of the video, so I'm going to narrate the video from time to time. Playing with two magnets here. So what we are seeing right now are two alike poles. So what happens when poles are alike? So they repel on each other. So this is kind of a review of our lesson last time, right? So they exert a push on each other. So now we go on the unlike, we go to the unlike poles. So unlike poles do attract, or they have a pull force on each other. So let's see what's going to happen. There you go. Okay, so that's the video for that experiment. So we will move to another experiment that you didn't get to do. That's on page 53. 53 of your student book. So it's about knowing which part of the magnet has the strongest point, or which part of the magnet has the weakest point. So we'll see both of them here. Although in the book, we were supposed to use paper clips, but in this experiment, the person or the scientist or the student doing this is using this powderized iron fillings, and we will see it later on. You're about to see it now. So, okay, the same. He is using a bar magnet. There is North Pole and South Pole. Yes. All right, so every magnet has an invisible magnetic field, meaning we cannot see it with our naked eye. Okay, so if you will place magnetic materials within that magnetic field, then that magnetic material will be attracted to the magnet. So this experiment actually is about visualizing or seeing how would we be able to see the magnetic field in some ways. So the bar magnet now is being attached, taped to a paper, an A4 paper, using a tape, and you will turn it upside down. So the magnet is between the paper and the surface of the table. So the magnet is here, upside down. Now that you know the north and south pole of the bar magnet, you're going to write it on the paper. And yes, you will sprinkle the iron filings on the paper. Okay, so when you put the iron filings on the paper, later on, you will find out the position of the iron filings. It's like a pattern. So this pattern is the magnetic field of this bar magnet. So what I mean by iron fillings, what are these objects? These iron fillings are these tiny little ferromagnetic materials. It's like a powderized iron. Of course, iron is an example of a magnetic material. That's why it can easily be attracted to iron. So what can we observe from this pattern, right? We can observe that. What can we conclude? We can conclude that the iron filings or fillings are attracted to the poles of the bar magnet, the north pole and the south pole. So more towards the pole, okay, not the center. So we can also conclude that if the iron fillings are attracted to the pole, meaning there is a stronger magnetic field in there. And we can also say that at the center, there is a weaker magnetic field. But one thing, we have to know that not all magnets look the same or are the same. So they have different magnetic field. It's not always, the pattern is not always like this. It depends on how the magnet looks and how the magnet is shaped. Yes, depends on the shape of the magnet. Okay, this is an example of a U-shaped magnet. Now you can see that the pattern is also different from the bar magnet, horseshoe magnet. Yes. Okay, so that's it for that experiment. Okay, so with that, we will be able to answer the questions below that experiment. Okay, so number one, right? Here are the steps, and but we will not be able to answer how many paper clips are attached. But on number 4, we will be able to answer greater or smaller. So let me share my screen with you and hope you answer with me on page 53 of your student book. Okay, please hold on. I am looking for your work textbook right now. Okay, we are on page 53. Yes, this one. Okay, I'm going to share my screen again. Okay, there you go. So the video that I showed you is the closest experiment to this. As long as the point is we should understand which part of the magnet has the weakest or the strongest magnetic force. So in the next slide, number 4 here. Okay, the stronger the magnetic force, the greater or smaller the number of paper clip attracted. So based from the video, the answer should be if the magnetic force is stronger, of course, there will be greater number of iron fillings attracted or paper clips, whatever magnetic material there is. Okay, so the answer here first is greater. The centers or poles attract the least number of paper clips. Of course, the weakest magnetic force is at the center. So what you will underline here is center. Okay, this shows that the magnetic force is the weakest. This shows that the magnetic force is the weakest at the center. All right. So that's it. You will answer the stronger the magnetic force, the greater the number of paper clips attracted. The center attract the least number of paper clips. This shows that the magnetic force is the weakest at the center. The same answer, center, center. Okay. What else? Did I miss something? Some of the questions we've already answered together. This one on page 54. Okay, I hope you got the correct answers there too. Okay, I think you have already understood this this experiment. And also we have answered this true or false, right? So let's just have an overview. Okay, this one. A force can be a push or a pull. We've already answered this last time. A force can change the direction of a moving object. Magnetic force is an example of a non-contact force. Magnetic forces can pass through non-magnetic materials. And number 5, a compass has a small magnet that helps us tell direction. Okay, so this is the summary of chapter 4, forces. So this video is also going to be about answering the workbook because there's still a lot of pages to answer in your workbook. So let's go to that one, okay? So let me stop sharing for a while. Okay, I've already showed you the book there. Okay, please hold on. Last meeting, I asked you to answer pages 28 to 29, 28 to 29, starting from magnetic force up to uses of magnets. Would you like me to also answer first few pages from 26 to 29? Okay. So I'm going to share my screen now. Okay, there you go. So this is page 26. This homework was given to you in the last two meetings ago. So you should have answered that by now. That is the first few lessons in chapter 4. Okay, so this was my homework last time. Magnetic forces. I know that you will be able to answer this on your own because first I have taught this in class, and the second I have given a video with about the same lesson. So you must be able to understand already magnetic forces. And now I already also giving you supplementary videos for you to understand magnetic forces more and more lessons after that. Okay. Okay. So you can just pause the video and find those answers. So now we're going to begin on page 30 to 34. We will finish all the answering pages on your workbook before we move to the next chapter. So the next chapter will be chapter 5 about energy. So there's a lot of things that will be talked about there. So let's get this over with. And if you have any questions, you can send me the questions in our line group. All right, let's begin. So on page, again, this is on page 32. I'm so sorry. This is on page 30 of your book. Let's go. Number 1, which of the following is false about forces? A force can be a push or pull. B, a force allows us to move things. C, a push makes things move towards us. Or D, a pull makes things move towards us. What's the answer? False about forces. The answer is C, because a push makes things move away from us, right? Away, not move towards us. When we push it, the object moves away from us. Number 2, a fisherman reeling in his catch is exerting, letter C, a pull and a push. The reeling of the fisherman, is this the one you turn when you try to try to lower the string of your bait, and then also get, if the bait has caught a fish, then you'll try to pull it back. But the motion is a pull and you push and then you pull, you push and then you pull. So there are 2 forces involved in there, which is letter C, a pull and a push. Number 3, this is a blank magnet. I just showed this to you in the video. The answer is letter D, horseshoe magnet or U-shaped magnet. Number 4, if a magnet is brought close to an iron nail, the iron nail will experience what? Magnet, iron nail. What will happen? What kind of force will the nail experience? A push force, B, a pull force, C, a pull force and a push force, or D, no force at all. The answer is B. Then iron nail will be pulled on by the magnet. Number 5, a football player kicks a moving ball in the same direction that it was already traveling in. So which of the following will not happen? The answer is letter B. The force can change the shape of the moving ball. So when you kick the ball in the same direction where it is traveling already, you can slow the ball or can make the ball faster, or you can even change the direction of the ball, but you cannot change the shape of the ball. Number 6, which of the following does not make use of magnets? Does not. Take note of that. A, compass. B, a computer. C, a pair of scissors. D, maglev train. The answer is letter C. A pair of scissors. A compass, of course, has a compass needle. A small magnet used to tell us direction. Computer has magnets. Maglev train is very much known for using magnets for its speed. Number 7, which of the following is true? Okay. Every magnet has a north pole and a south pole. A magnet has an east pole and a west pole. A magnet can be made of wood. A magnet can exert a force on sand. The answer is letter A. All magnets have north and south pole. Number 8, a carpenter accidentally dropped a steel nail into a glass bottle of oil. So imagine, steel nail into a glass of oil. So what can he do to take the steel nail out without dirtying his hands? So based from the illustration in your book, what could this carpenter possibly do to avoid mess in his hands? So the answer is letter D. He can hold a magnet on the outside surface of the bottle and move it up towards to get the nail out. Letter D. So number 9, Chan has a bar magnet. To find out the poles of the magnet, he can what? Place the north or south pole of another magnet near this bar magnet? Yes, letter A. Because letter B, tie a string to this bar magnet and hang it in the air. So what's going to happen there? Nothing. Place this bar magnet near a wooden plank. When we know that a wood is a non-magnetic material. Letter D, places bar magnet close to the pile of paper clips. So the answer is letter A. Number 10, which of the following materials can be attracted by a magnet? So you need to know what are magnetic materials and non-magnetic materials. The answer is letter C. From the videos I made you watch, the one we used in looking at the pattern of magnetic force is iron filings or fillings. Number 11, we are now on page 32. Which of the following are examples of non-contact forces at work? The examples are A and C. A ball falling to the ground, non-contact force, gravitational force. And letter C, a magnet repelling another magnet. A magnet can exert a force from a distance. So both are non-contact forces. Number 12, iron fillings are evenly sprinkled over a piece of paper. So we know this already. So a magnet is then placed onto the piece of paper. So a lot of the iron fillings will be gathered near where? A and B, right? To the poles of the magnet. Right. So the strongest are in the poles. Strongest magnetic poles are in the strongest magnetic force are in the poles of the magnet. Number 13, we are now on subjective questions, meaning your answers can be considered even if I tell you the answer and you can still find another answer that can be accepted as long as it is based on a book and it is correct, and that's what we have learned, okay? So number 13, Chan is helping to do the laundry. So he opens the door of the washing machine. What force does he exert on the door? Of course, he is pulling the door. So he exerts a pull on the door. Letter B, he puts his laundry and closes the door of the washing machine. What force does he exert on the door? If he opens through pulling, of course, he will close through pushing. So now he exerts a push on the door. Number 14, we are now on page 33 of your book. He wrings dry a wet shirt. What forces does he exert on the shirt? So this is a combination of a pull and push force. It's a twist. Yes, so two, push and pull. Number 14, a baker needs a bowl of dough. Baker needs like this, making like a circular shape. So he stretches the ball of dough. What is the effect of the force exerted on the dough? Remember that forces can change the shape of an object. So the force changes the shape of the dough. As long as you answer change the shape, that is check. Letter B, he flips the dough in the air. What is the effect of force exerted on the dough? The forces causes the dough to move. Remember, what does force mean? Letter C, he catches the dough, catch. It goes up, right? And it falls. He catches onto his hand. What is the effect of the force exerted on the dough? The force causes the dough to stop, or it stops the dough from moving. Number 15, we are number 34, page 34 of your workbook, the last part. Okay, for this part, I'm thinking that this should be, wait first. Okay, I want this page to be your homework, all right? Because I've already helped you with almost the rest of the answering pages in your textbook and your workbook. So, excuse me, this part will be your homework. Okay, so that's it for today, grade 3. I hope you learned something, and I will be able to help you answer your workbook and student book at the same time. So don't worry, I'll be sending a summary of what we have done, what is the content of this video, and which pages you should answer. All right, I'll see you again next time. Goodbye.